In this example, we are given that a slightly divergent beam of charged particles accelerated by a potential difference V propagates from a point A along the axis of a solenoid. And here we are given that the beam is focused at a point at distance L from A by two magnetic induction values B1 and B2 one after another. And we are required to find the specific charge of the particles. Now in solution we can see if this is a solenoid and along its axis we know that magnetic induction everywhere exists along the axis of solenoid, and say from point A slightly divergent beam of charged particle is ejected out. So we know that all these particles will follow a helical path, and say these are focused at a point P which is located at a distance L from the initial point A. We know that in helical path, after every pitch, the particle reaches a point which is just ahead of the starting point. So we can say point P must be located at some distance such that this L is an integral multiple of the pitch of helix. Then only we can say all these points will be brought into focus at point P. Or at every point after a pitch, all these particles which are ejected will be focused. Now here we are given that the focusing is done at two successive values of induction. These are B1 and B2. And we know the pitch of helix is given by 2 pi mv cos theta by qb. And as we are given that beam is slightly divergent, we can take cos theta as a unity because the angle is very small. So pitch of helix in terms of the kinetic energy, because we are also given with potential difference, this can be written as 2 pi momentum mv. I can write as root of 2 mev divided by qb, that is the pitch of helix. And in this situation we can say for B1 and B2 these are focused, so we can write for magnetic induction B1 we can say the length L is n times the pitch of helix, so which can be written as 2 pi root of 2 mev divided by qb1. And for magnetic induction B2, as we know, for higher value of induction pitch is less, so the seam length can be written as n plus 1, because one pitch must be increased, then only focusing will take place. So here it will be 2 pi root of 2 mev by qb2. From these two equations 1 and 2, if we subtract 1 from 2 by taking B1 and B2 on the other side, you can see we are getting the result to be B2 minus B1 multiplied by L is equals to 2 pi root of 2 mev divided by Q. And in this situation you can see the value of Q by M can be obtained by squaring. Here you can also take the charge Q instead of E, because I've already taken charge as Q, so I just replace E by Q. So in this situation, a squaring, we are getting B2 minus B1 whole square L square is equals to 8 pi square MQV by Q square. One Q gets cancelled out here, and remaining Q by M we can directly calculate as 8 pi square V over L square B2 minus B1 whole square. That will be the answer to this problem.